Hi everyone, thanks for joining the session Git and DBB for ZOS for COBOL and PL1. I'm Corinne Alpers from IBM, and this is our speaker, Rosalind Radcliffe, also from IBM. Before we begin, I want to talk about a few things. One, this session is being recorded. If you're not interested in participating, please leave and find another session. Also, we only permit our guy back there to record, so please don't stream and record on your phone. Secondly, your feedback is very important to us, so make sure you fill out one of those good surveys. Thirdly, this is an election meeting, and so if you are a representative, make sure you vote on Wednesday. And if you are a member of the press, make sure that you have identified yourself to Rosalind, and Rosalind will be answering questions throughout the presentation, so feel free to just jump up and yell. And lastly, please turn off all your cell phones. Don't be rude. Thanks.
Thanks. So thank you. Cables. So welcome to this session. We're going to have a fun hour talking about Git and DBB and how you can do modern development practices. I am Rosalind Radcliffe. For those of you who don't know me in the room, if there is anyone, I'm an IBM Distinguished Engineer, and I'm responsible for DevOps for enterprise systems. What I do most of the time is spend time with clients, helping them transform their processes. But DBB and Git running on ZOS happens to actually also be my product. So I get to have fun talking about something I actually do as well. So what are we going to do in this session? We're going to talk a little bit about Git and why to use it, though if you were in my last session, you've already heard that. We're going to talk about what is dependency-based build and why does it matter? How does it all fit together? And really, we're going to have a bunch of demos, because demos are more fun than slides, and I get to have more fun, and then I get to live with the demo gods, so if they break, well, oh well, life goes on, but we'll show what we can, and then we'll summarize the capabilities. Who in the room has not heard of Git? Please raise your hand. For once, I'm in a room and everybody knows what Git is, so I don't have to do this. No, that was Jerry being silly. That was Jerry being silly. So since everybody knows what Git is, I don't have to do this time. The reason I do this is because one time I did an hour session on Git. And at the end, somebody asked me what Git was. So I've learned my lesson. But since you all already know about Git, then this doesn't matter, other than somewhere near 48% of all SEM usage, 49% of all SEM usage is now on Git, and people continue to move and adopt Git. I included these links in here so you can get them. It is important to recognize that in order to use Git on ZOS, we do need the Rocket port of Git. That gives you the ZOS side of the capability. It does the ASCII to EBCDIC translation for you. It's also important to recognize that unless something has changed, please do not update your Windows Git to the latest Git. Rocket did a wonderful thing. They added ASCII to EBCDIC translation into Git. It works great. And Windows decided it was a really good thing. And so they used the capability in their latest update to do code page translation as well. And so if you update to the latest version of the Windows client, you will have a small problem. So please don't if you want to use the Rocket Git for ZOS as well. Just a slight warning. They're working on it, I'm assuming. Dependency-based build. So if we have Git in the environment, and we have a modern source code manager, then we need a way of building. We need a way of building this source. And today, most people use their existing library managers for this build process, or they use JCL. It's the way you build. Well, if you're moving to Git, and your source files are now sitting in the ZFS, I now need a way of building them, and they're not really sitting where you expect them. And can I build them in a modern way? So what we did was we decided that we would take Groovy and create a modern build tool. Now, why did we pick Groovy? Well, actually, we built a set of Java APIs, and you can use whatever language you want to call those Java APIs, actually. However, we wanted to build a set of samples, and we actually started with Ant. And when we provided Ant in our beta, we got some feedback. The feedback went along the lines of, Ant is old. Why are you doing that? So we asked, what should we use? What's the right answer? And the answer we got was Maven or Gradle. We did a lot of looking in Maven and Gradle was probably the right answer, except Gradle is highly Java specific. And so we went, okay, we'll use Groovy, which is what Gradle is built on, and come up with how to do COBOL PL1 with just Groovy. And so that's where we ended up. We provide MVS exec, TSO exec, ISPF exec, and with this, you can do general system automation. And there are some people in the room who have done something with general system automation, and there might be a session on Wednesday morning at 8 o'clock talking about some of that as well, in which we'll talk about how you can actually do system-type system work with Groovy on ZOS. We also have somebody else in the room who's provided some samples to do some capabilities, which I'll show you in a little bit. But it basically means I can now use Groovy to do anything that I would have used JCL for, almost. You're not replacing your JCL in the scheduler, because the scheduler still expects JCL. But if I'm writing something, if I'm trying to automate some task, if I want to do something in the system, I can actually use Groovy for that. That's not actually what we created dependency-based build for, but it's a nice side effect. I now have Groovy for Z, and you can do all this automation. What we built it for was the dependency part. So we also have a dependency scanner. One of the key critical components with COBOL, PL1, assembler, is you need to know your dependencies. What are your includes? For example, with COBOL, what are your copybooks? What are those other files I need? So we have a dependency scanner. We have the ability to store build reports. So you can create a build report and store it in the database. We'll store this dependency information so you can use it for future builds. You could also use it to query. So you could have a script to allow developers to query the system to say, what are my dependencies? You can also do the reverse. So if you, for example, change a copybook, what are all the programs that are affected by that copybook change? So you get both sides of the picture. When we look at this picture, this environment, this is sort of what you end up with. You need a way of using Git. So in this picture and in my example, we have eGit working with IDZ in my environment as my editor. You need RSE in the back to talk to IDZ. We're using the ZFS. We have the DBB toolkit running. We have our web app. That's the thing that stores the dependencies. And here you'll see in my example, I'm using GitHub. It could be GitLab. It could be Bitbucket. It could be any server with the Rocket Git. You'll notice my little line here, the ZOS part on the bottom, something else on the top. It says x86, but something else. Wherever you're running your server today for GitHub or Bitbucket, it doesn't matter where you're running it. The same one can be used for your COBOL, PL1, etc. There's nothing different about the source code that you're putting in from the Z side. It can be your existing Git environment. Rocket Git's the only piece that you need different, and that runs on ZOS. The Jenkins slave also can run on ZOS, and the Jenkins server is going to run wherever you're running it. Doesn't matter. you'll see we have Groovy and running on the system. We have artifact repository. You can now put your output in an artifact repository. So you can put it in Artifactory or Nexus. Take your choice. So we're going to do a demo and show quickly how the developer would work and then jump into the function. In my demo, I do have IDZ in the front with the SCM. I have IBM DBB and I have Sonar running, and I have Urban Code. And so this is kind of my pipeline that we're going to show. And we're going to see how the demo gods are doing now. Because there's always a challenge. So as I expected, bye-bye ZOS, let's get you back. So the first thing I do have to do is connect to ZOS. And as I explained earlier, we have a nice little firewall running inside IBM that I have to get through, and I have to type my user ID right. And I have to type my password that, of course, I had to change last week correctly. And another password I had to change. Got in. Okay, so normally you wouldn't bring up a 3270 interface in the middle of my IDZ, but it's the way that I've figured out to get past my firewall. So we're done with that piece. Done. Here's Git. This is actually the eGit client sitting here. I have full access to my Git source, and I can do what I need to do in the environment. If I want to interact with a Git environment, I can simply do a Git pull, and I will get the current source that's sitting out there. Now, I'm up to date, because I did that this morning, or this afternoon already, and so I am current. From the IDZ view, I can make whatever change I want to make to this program, and as I did earlier, testing. I don't make changes to code, because that would be a pain. However, cross your fingers, people. I'm going to go down here somewhere and screw up this code. That should give me an error. So I've got a nice error, and IDZ is very nicely telling me that I already have an error. This isn't correct. Not a valid COBOL syntax, right? I mean, it's not a real statement. But I have now changed my program, and I've got an obvious error in it. I can now do a build, and this RTC for fun. Yes, that is my password. You can tell I do have a bias. Okay. So I'm going to do my build again. And here I'm going to point out this time, I'm pointed to a Groovy script. So this is actually the script that I'm going to run to do this build. I've also got my data sets, my hierarchical file system, and the data set I'm going to build to. But that Groovy script is important because that's the Groovy script that I'm going to be using to do this compile. The important thing about this Groovy script is it's exactly the same Groovy script that's going to be used in my pipeline. So there's no change in the way I build from a user's standpoint to a pipeline standpoint. So I'm using the same script. There's no, as some people do, they modify personal JCL to do their personal builds first, or they do something in their own environment to do a build first. This is using exactly the same thing you're using in your official build process. I already know these are up there. And I don't actually need to discover the dependencies because I know the copybook's already up there because I did it this morning. Now, this should fail very nicely. And we should see, yes. So it failed very nicely. I have an error, and it told me it failed. And I very nicely have my error feedback from IDZ that tells me I screwed up royally. So here's my error feedback. Now, if I had moved away from this line, it would be nice and I could double click and get to where I needed to be, but I didn't. So I very easily can see the errors that I have in the environment and I can easily fix it. I want to make it easy for users. And it's still this local file that I'm working on. So I haven't had to worry about checking it in. I haven't, in the sense of delivering it to somebody else. This code only affects me. Doesn't affect anyone else. It allows me to work entirely independently of anyone else. And just because I'm paranoid, I'm going to make sure it actually builds. Save it first. Bill's sitting there going, "You forgot to save it, Rosalind. You know that you screw that up in your demos." Oh. Okay, so this time it's actually going to work. Oh, and I forgot to uncheck. There it goes. So this time it's going to work. Now, yeah, clean. Worked just fine. So I have my successful build. That build that I just did is right here. So I have a Groovy script that is what actually is doing my build. As a developer, I don't care about this. As a developer, I probably don't have to worry about changing this Groovy script because it was built for me and I'm just using it. But as a release person or the person who defines this, they're the ones that are going to define it. The other thing that's important is I have this little build directory in the middle of my program structure. You probably wouldn't. This is a demo system. So I have my build scripts with my source code. Normally, you'd have a separate repo, please, that has all your build scripts in it, your build definition, your standard Groovy. I'm going to COBOL build, my PL1 build, all of those would normally be sitting in their separate repo, so developers wouldn't change them. They wouldn't have anything, they wouldn't have to change them. They don't need to change them. But in this example, we have them here because it makes it easier from a demo perspective to show off this capability. And you can see I've got the ability, it is a full scripting language. I can do what I need to do in my build definition to do a build. And I'll show you a few more of those in a minute. I can now check in this code and I can kick off the pipeline. But as a developer, I'm mostly done with my work. So I am going to go check it in so it's sitting there. And the change is not just sitting on my machine. New change. Fix a problem. Not that I actually had a problem, but oh, I pressed it twice. So I've now committed that, and it has now been committed and pushed. So that file is gone. And as a developer, I've now done my job. Let's look a little bit more at what's going on from this build standpoint. If we go to the Git environment, and I'm going to get to the right one. That one. This one is the GitHub environment that is the Git that I am connected to from the example that I did. And here are these build scripts. And here are the test cases. And if you see here, I actually have a set of test cases that have been built for this. And I have a set of tests here. That's the setup for the tests. But I have a set of test cases that have been created in here for testing my program. And I can find them. Here they are. So I've created a set of tests. These tests are in my Git environment alongside my source code. And so when I run the Groovy script, it's going to run these tests alongside my program. If I made a change to the test program, it would rebuild the test program as well, because that would be a change that would need to be rebuilt. So system looks at what are the changes in the environment in order to build them when it gets to the pipeline build. In the user build, it's just going to do the one program I changed, because that's what I just changed. This is available, okay? Back to my build script. The thing that's important in this build script definition is you are creating the ability to compile a program. And in Groovy, what we've done, well, this is just Groovy. Let's just be clear. This is Groovy with a few extensions. So anyone that knows Groovy, this makes perfect sense to. Someone who knows JCL, maybe it makes a little less sense to start out with, but we'll go through it. This is just Groovy. It looks like normal Groovy stuff. But if you happen to be a Z person, you notice some Z things in it pretty quickly. If we look, for example, here, my temp create definitions. That looks an awful lot like a Z line that you might have somewhere in your JCL, right? If we go down here a little bit more, you'll notice we've added a function, copy to PDS. So this is built in for you. It's an easy way to take a file out of the ZFS and move it into a PDSE. By the way, it is moving it into a PDSE, even though it says PDS, just use PDSE. Always use PDSEs. I should have made them fix that before they ship, but whatever. In this particular case, you can also see we have a simple update that allows me to copy all the dependencies for this program to the PDS as well. So if I'm compiling EPS payment like I was, it will copy the required copybooks also into the PDSs for me. Script does it, it's right there. Now, the COBOL compiler has fixed this problem. Okay, the COBOL compiler has added an enhancement. Since this is being recorded, they would prefer those words. Added an enhancement to the system to allow you to not have to actually copy the copybooks. You can leave them in the hierarchical file system, and you can set your compiler to pick up your copybooks out of the hierarchical file system and the system copybooks out of PDSEs, and you can do that concatenation. And so you don't have to do that copy, actually, anymore. But since we have clients who are not yet comfortable with the idea of building out of the ZFS, we still do this copy, so they see that that can be done, but you do have that other option. As you scroll down, you'll see something that looks something kind of like JCL, sort of, in the sense that I'm creating all my DD statements, just like I would in JCL. Here are all my DDs. These are all the DDs I need. These are all the DDs you need if you're in COBOL v6 in order to build the system. And then I have a simple compile. So in order to compile, I can specify my compile, and then here you see I'm specifying compile options, and you'll see there's this is_kicks. Our dependency scanner that we're using not only identifies whether or not it's what its dependencies are, but it also identifies, is it a kicks program? Is it a DB2 program? So that flag is actually set in the database, so we have that information available. The scanner can identify it. There's no reason for you to have to do something special. It's done for you. And you'll see here, we add the error prefix when it's a user build so that I get my user feedback in this environment. And I execute my program. So this is an example of a simple compile. It's actually slightly more complex than simple. The question was, can I save off the compile options for each of the individual programs? So one, My first statement would be, you should remove a whole bunch of the compile options you're currently using because you don't need them anymore. And you're probably using a whole bunch of settings that may not even be valid on the compiler anymore. And last time I looked at somebody who was migrating, they had a whole bunch of print options on their compilers for the paper printout. Okay, now that I've said all those things, what you do is you have definition, you can specify metadata for programs, and so in that metadata you can specify what are the options that you need. In this we just did the simple kicks db2, but you can specify it based on different parameters or categories. So for example, you could have a file extension determine what it is, or you could say this program in particular has these options. It's a simple matter of programming, and it's your programming. Isn't that nice? I don't have to do it. Oh, it is actually a simple matter of programming, but the definitions of metadata, we did the kicks in DB2 one. We also show in one of our other samples a way of specifying metadata and compile options based on specific things, so you can just take the sample and use it. We want to make it as simple as possible to allow you the flexibility that you want or need, but also not make these too complex. We do have a slightly more complex compile here, and the reason I wanted to bring it up is it has another feature that I wanted to call out, and you'll see here we have this thing called MVS job. Now let's be clear, this is not JCL. You're not submitting JCL, but we created a concept of an MVS job because in JCL, you're used to passing temp data sets between things. So if you're doing an MVS exec, and then another MVS exec, and then another MVS exec, and you want to be able to pass your temp data sets between them and have us handle the allocations, yeah, well, we will. So you have an MVS job, so you can do a set of things, like a compile and a link edit, et cetera, all in one set of things and surround it with a job. So you can do things like you were doing in a prior system defined in the script. Now these are the compile for individual. I'm going to have one for COBOL. I'm going to have one for PL1. I'm going to have one for assembler. I'm going to have a language definition, in a sense, for each one of those. And yes, the words I use might remind you of RTC, because that is a little bit of my heritage. And if you don't know what RTC is, it's Rational Team Concert. These processing, like for example, we have BMS processing. This is another one. We need to do BMS processing. So we have each one of these language definitions. So for each one of the language types, I'm processing it appropriately. And then we have the larger Groovy, build.groovy, that is what brings these together and determines what you're building and the order you're building in. And so you have the overall build script that captures the dependency information out of the changes that you've made and then allows you to do the individual processing in the order that you want. So it's going to process the set of files in the order of BMS, compile, link edit, COBOL compile, and ZUnit compile. Makes sense. That's the order you would logically want to do it. You should look at me and go, what? Why am I doing a compile, a link edit, then a COBOL compile? Don't you do the link edit after the compile? That COBOL compile had the link edit step in it. The other one had them separate. So we're showing examples of different ways you can do it. It's up to you, what makes sense to you. So that's why they're split up that way. And they're all samples to give you an idea of how you might want to do things. And in this, we also generate a build result. We create a file so that you can see what has been built, and you can get that information. And any build that you do actually has that information. So for example, those builds, those user builds that I did in this environment, if I go to the work directory where they were created, and I open the file, that's already open, you'll see this build report is created at the end of the build. And in the build report, I specify what's the program that was built. I can include the dependencies, so I can show or hide the dependencies. I can specify the data sets that were built, what was generated, what was the deploy type. That's wrong, it's not a Kix load, okay. And the log. So I get this report every time I do a build. And if I did a build that included 5 different things or 6 different things, I'd get a report with as many things as that build contained. And it's all generated by these scripts. Yes?
Can you see the build outside of the Eclipse, like say an auditor or some build?
This is a log file that is sent and can go to, or would go to Jenkins. And so it's now in Jenkins and is visible in Jenkins as it is visible here. So it's in the system and stored. It's also stored in the, Jenkins is probably where your auditors want to pull it from. But we're also storing it in the DBB web server, so you have a secondary place where they're all stored, where you can get at them. So we have at least 2 places that they can be permanently stored if you want it. It is up to you. You can choose not to do that. Since Jenkins probably has all the other build results for all the other builds you're doing, it's the logical place to store it. You could also generate a more auditable file instead of a pretty HTML file. We generate this purposefully as a user-friendly file for visuals. The same data can easily be generated in an output file that is better for processing. Or you could process the HTML. It's totally up to you. We do, in an example, show the creation of a ship list file, which is an XML file that specifies all the files that have been built to allow you to deploy it. So you could also use the ship list if you wanted to as the audit file. Take your choice. Got multiple ways. I can give you even more. Oh, I could give you even more, I'm sure. We want to make this output as consistent with any other platform would be, but we also want to make it pretty. In ZOS, we do have some differences. The dependencies in particular are one that the includes that we have are slightly different than a Java class, et cetera. And so we want to make sure those are called out. The other thing we do provide is a sample that allows you to put the version of the file and the dependencies, namely the Git hash, in this report. So you can have another column in this report that has the Git hash. And that says this is the version of the file and the version of each one of the dependencies that was actually used in this particular build. Good luck finding that information in any other system other than RTC. Oh, now I'll be polite again. The other thing we did in this sample was try to give you as many different pieces of information that would be helpful. So this impacts.groovy is actually what shows you how to do an impact analysis to understand if I change a program, what has been impacted. We also have a number of others, but if I go back to here, and I go here, that's the right one, right? Yeah. If you read the top, you'll notice very small writing, but it's github.com. That's not IBM, that's github.com. That's the external GitHub Any and all of you can get to that. And if you go to IBM DBB Dev samples, you will see the samples provided for you to go see Groovy doing this. So you can go out and see all of these samples. You can go see all of the examples that we have created, and we update this every quarter with every release, or more frequently, depending on what comes out. So right now we have a set of things available as samples, and here, the reason why I said sort of, the simplest, here is the simplest program that somebody could create, a hello world for COBOL. When have you ever seen a hello world in COBOL? Okay, but they created one. So the simplest Groovy program possible for a COBOL compile, which has to have all of these DD statements. Here we go. Very simple, very straightforward. We wanted to give some simple examples of how to do this. Now, you'll notice in this example, it's hard-coded values. Oh, we were nice. We removed people's names. Simple example, copied into doing the build. So we wanted to make it simple. We're also going to do a hello world or a version of hello world in assembler. Yeah, hello world in assembler is a little strange, but we're going to do a hello world in assembler and post it so you can see how to do an assembler program. We want to put an example out here for anything and everything that makes sense for users. The other thing that's out here is something I would recommend paying attention to anyway. We created a set of migration information to go from PDSs to a ZFS file structure. So if you're in a library-based system today, if you have a homegrown system, whatever you have today, SCLM, whatever, if you want to move your source code out of it, we provide a set of information and scripts to help you do the migration. The thing I'm pointing out here, though, is something that is a catch that if or when you move to a modern SCM, you need to pay attention to. ZOS COBOL PL1 is in EBCDIC. No surprise. When you're storing source files in Git, you're going to store it in UTF-8. UTF-8 is a different code page, so you have to do a translation from EBCDIC to the UTF-8. There are a few characters that are non-round-trippable. So if your source code contains any one of those characters somewhere in the line, they are non-round-trippable. So you can't go from EBCDIC to UTF-8 and back. Small problem. Big problem. So what we've done is we have a way to identify which programs meet this criteria. You have a choice. You can take that program and bring it into Git in EBCDIC, so it stays in binary, and it comes down to the workstation, to the Mac in EBCDIC, and you can still read it with IDZ, because IDZ knows how to handle this. It's wonderful. Thank you, Bill. Otherwise, you can fix the program. So if you've hard-coded hex values in the middle of your program, you could fix them. We have had some clients who have gone in and fixed every one of their programs. I can name the one. Yeah, I can name the one. The rest of them, leave it in EBCDIC. It probably depends on how many you have and how much effort it is and where it appears as to whether or not it matters and whether or not you're going to do it. But this is an important piece of this translation and this moving. We wanted to make it easy for you to understand in this migration. We wanted to make it easy for you to deal with this migration. We wanted you to have all the information. We didn't want you to trip over this one, because You might think there was a problem with Git. It's not a problem with Git. It's a problem with your source code. But it's not a problem. It can be handled. It's just something to watch out for. Now, this is the external GitHub. That is internal GitHub. Here is another internal GitHub that we have. And this is a community inside IBM to help us share inside IBM. Right now, it doesn't have a lot of samples. We're going to add more samples inside IBM as teams inside IBM create additional samples. But very nicely, very recently, someone added a few samples for me. And if you notice, it was an hour ago. So this really is recent. So one of the things that is important to recognize is we did build Git DBB combination to be a build solution. But if you're doing an automated pipeline, there's other automation you need to do. There's other pieces of this automation. I need to be able to do things for automated testing. I need to be able to do things in this pipeline, run my automated tests, run things for my tests. I need to deploy as well. We want to make these steps easy to do and fully automatable, so we want to provide more samples. This happens to be a sample that you might not normally use in a build or deployment script, but you might if you were provisioning a new system that you wanted to create a new system and to do things on. But here's some simple examples, or not quite so simple examples, but some good examples of functions you can do. So an example of creating a user ID on a ZOS system. So this is a DBB script. It's using Groovy for Z capability in order to run this function. It does not require the dependency scanner, and it does not require the web app. So you can do this with just the toolkit, just having the toolkit installed. And you can create a new user ID, and this is a sample. Our intention is to get samples like this posted externally as well in our samples library, so you have more options in what you're doing. So you can do things multiple ways, so it's easier for you to automate. The idea with this is really to bring Groovy to the Z platform. So you can do whatever you want to do in your automation tasks instead of having to do it with JCL or some way you would have done it before. Questions?
This only working with RACF?
No, well, this one's RACF, but that doesn't mean someone couldn't create one for something else. I didn't say you were going to do that. The person who created it is sitting behind you. There is a project along with a customer to do a set of automation tasks. And somehow we didn't manage to get the session at this share, but we're going to have the session at the next share, having hopefully the customer speak alongside of some of the automation that they're doing. So this is a customer-based example to show what somebody can do with Groovy. And you could do it, I mean, as long as there are commands that you can run, or if you could do it in JCL, you can do it in Groovy. You can run any MVS, TSO, or ISPF command. And yeah, I can pre-announce. Rosalind has a really bad habit of talking about future direction, even when I'm being recorded. So plans are subject to change, but we will be adding additional gateway support. So right now we use the existing ISPF gateway, but we'll be adding interactive gateway support as well. I mean, that's coming out in September. It's not very far from now.
You tied this into a system like Remedy? Or?
Yes, you could. So one of the things that people would somebody would want to do is cause, when a ticket happens, something to be kicked off. And you could tie Remedy into Jenkins to have something kicked off, or you could use Groovy to tie them together. There are all sorts of different ways that I would tie things together. I would definitely say that using Groovy behind the automation to say, ticket, create a new user, have it go run. Or ticket, create a new system, go run something. Or ticket, create a new Kix region, go run something. Those are all things you should be able to, and you can automate today, and you should tie into whatever your system is, your portal is, to allow users to request those things. So if it's Remedy, if it's something else, doesn't matter, you should be able to tie them together. And that's the point of doing this kind of automation in a DevOps pipeline. Everything is automated. Nobody's doing anything manually, so users should be able to request the function on their own and have it done. Other questions?
Is Groovy like running as part of a shell or something under
It is running in Java. It's a Java process. So it's running as Java under Unix System Services. So it runs on the zip nicely. Now, obviously, the compile still runs on the general purpose processor, because the compile itself is going to run on the general purpose processor, but all of the automation around it will run on the zip and will run under Java. We've also done work to do some daemon processing to allow you to have multiple processes run at once, so you can do multi-threaded build. Also doing some work for daemon processing to allow you to not have to restart Java when you're doing this. So if you have multiple tasks and you just want to keep the Java daemon up and running, we're working on that as well as things to help improve the processing of the system as you're going through. Other questions? Okay, back. Yep.
Can you compile the Groovy so you have a common set of internalized for company jars and then as well as extend them if they need to?
Yes, you can do compiled Groovy and extend, and as a matter of fact, in the next release, we'll be shipping a template to make that even easier for you. So you can compile your Groovy and provide it. It's also another way of improving performance if you compile the Groovy so that it's running that way. The other way you can do that is if you want to limit people's access to it. I mean, if it's a Groovy script and it's sitting there, a developer is more likely to go change something. If it's compiled, then they're not going to be. I mean, there's some things in there that you might want to think about. If you want people changing it, if it's compiled, then you've limited that ability, but you do improve performance, so you've got some trade-offs. The other thing that's important to recognize in that, it is highly probable that you will have all these scripts managed in some other repo and deployed as part of the Jenkins build or deployed as part of some system. So when I did my user build and I selected the file that was in my local system, more likely I would be selecting something on the ZOS system that's already been deployed for me so that I have no chance of changing it. And I can do that as well. So I can select something that says I'm going to run it from there. So they're different. We've tried to make it so that companies can decide what their standard is for how they're going to do this. The other thing that's really important in this thought process of moving to a modern SCM and moving to an environment is how are you going to structure your source code? You're building a set of scripts to do your builds, and they're going to work off your source code structure. What is that source code structure going to be? You're no longer tied to a PDS. You don't just have members now. You can have whatever folder structure you want. So I can now create folder structures for different things. And I can choose however I want to create a structure. And I could choose, though I don't know I would, I could choose to break it out like this by type. I could choose to break it out by different parts of an application. You could choose how you want to structure these things. In the case of one organization that has migrated, that's fair. There are an external company. They have chosen to create a repo per load module. Not sure I would agree with that, because they're going to have hundreds of repos, thousands of repos, but that's how they've chosen to do it. So whatever the files are that make up that load module will be in one repo. It's their choice. There are other choices that people have made in migrating, but that is one of the key pieces of this migration. Now that your source code can be put together in different ways, you get that option. So you can see some of the things that we're working on here. Multi-threaded build. Another one that is here is publish load modules. So one of the things that I have been working on ZOS to do is this ability to publish load modules to Artifactory. And so this example will show taking the load modules out of the PDSE and literally publishing the package into Artifactory so that it can then be pulled out of Artifactory as part of the deployment process. And so you have this deployment artifact that is stored alongside all the rest of the artifacts. And this is the sample that will allow you to do that. We will create a sample for Nexus as well, so we'll have both samples. We also already have in the sample the creation of a UCD package to be able to deploy a UCD package. So you've got the different choices in the samples that are available. Other questions?
You and I were emailing about this as the scalability of this running under USS. So if I've got multiple groups that are working with this, where are the elements where scalability is going to be?
The question is, where are the, I'm going to summarize it, where are the considerations for scalability or working in a large-scale organization? Where are we going to run into any limitations? My first answer is, why would we? Okay, that's a little too sarcastic. So the first answer is, I'm doing a user build, so that's each individual user is going to be kicking this off in their own space, and they're going to be doing a single build probably, they're compiling a single program. So that's a single program build in each individual space. I don't see any usability or scalability issues in that. When you get to doing a build in a normal pipeline, let's say you change 3 files, you change 4 files. The speed at which it can do 3 or 4 files is going to be irrelevant as well. So I don't see that as a problem, even having multiple teams working. If you got hundreds of teams working, then you would have to decide if you want to allow hundreds of processes to run at the same time, but you would configure that in Jenkins to decide how many you would allow to kick off at once, because right now you have a certain number of initiators, and you only allow that many jobs. Well, how many are you going to allow? You could control that in Jenkins. The next one that is the scalability one is, let's say I want to recompile my whole application. I want to recompile all 10,000 programs. How many of you ever recompile? You can't raise your hand, as in kicks. The rest of you, how many of you actually recompile your entire application at any time, ever, like in the last 10 years? Anybody? You don't count either. Okay, anybody that's not an ISV? Yeah, okay, I got it. So yes, I think there's a problem in that. I actually do. We're looking at it. That's why we have multi-threaded build, because we think we need to do multi-threaded build to make the ability to build, 1,000 programs quickly or 10,000 programs quickly. So yes, we're going to fix it. I don't think it matters in general for most clients. It would matter, for example, in a COBOL v6 migration. If I were on COBOL 4.2 still, that I shouldn't be. No, I'm not going to ask. Moving to COBOL v6, I should just recompile everything and see what happens. That's another case where it would be nice to do multi-threaded build. So yes, we're working on multi-threaded build. We'll have multi-threaded build as soon as that GAs. So it'll be there and we'll have solved that problem. I can't figure out off the top of my head another scalability item yet, but we still need more users using it to get more feedback if there's some other area we need to know about.
You've just got to be careful with your USS setup, the file systems that you create.
Oh, yeah.
If you have all of your users using a single /u, for example, it's going to get full at some point. There's ways to have automatically created OBS data sets for each user, for example. It's always good to have separate or split out your USS in kind of a sensible kind of way, so you're not going to blow a single data set.
Okay, so the proliferation of
Exactly. Like one of the things we do, like the /var, is not everything goes into /var, and that /var is actually just a series of mount points, and then we mount the various different things at different directory points in /var, so that they're all self-contained, and we're never going to blow /var, because if you do that while your system's running, you're in a bit of trouble to sort it out.
So,
Git and your USS file structures is the Git repositories, right?
well, so for the purposes of the recording, the conversation that just went on had to do with the ZFS and your home directories and the directory structure that you're saving files into, and you have to be intelligent about how you set those up in the first place so you're not putting everybody under /u and letting them blow the system, for example. And then I forgot the next question.
The only thing contained in the USS.
Oh, yeah. So the other half of the question was, but what are you putting in the USS system? And it is the Git repo when you're doing a Git clone. As the Jenkins server, when you're doing a Git clone, it's the Git clone, but it's also the working files. It's also the output, as in the listings that get pulled back. And it's probably also the objects that you're going to bring back and the load modules that you're going to bring back, because you're going to zip them up and put them in Artifactory. So you need space to be able to put them temporarily and then pull them down to Artifactory. So they shouldn't sit there, but they'll need to go through there. So that's something to keep in mind in this space allocation that you're dealing with. So you really want to make sure you have the right space in your ZFS, and you want to make sure you're managing the space in the ZFS, because it will matter. It will matter a lot. And that can blow out, and when that blows out, you have lots of interesting side effects. And by the way, whatever you do, don't let /etc or whatever it is, /temp and /temp fill up. Just don't. /var and /temp, just don't let it fill up. Do whatever you can to never let those fill up.
What I'm hearing is there's enough experience right now, people have done this in some sense of scale, that we have the considerations. Usually it's the things when you look backwards, you go, should have thought of that. So somebody's already done enough. If we're planning a new implementation of this, someone could go, okay, look, think of these 10 things, plan this stuff out, and you won't run into trouble.
Yeah, I think there's enough. The question had to do with, is there enough experience already to be able to set somebody on the right course? And I think the answer is there is enough experience with the experience we've got with RTC, because we've used the system that way. I think there's enough combined experience in there to be able to get someone started in the right way. The one other thing I will say is, and the comment I made, you have to have an OMVS segment for your users, please. I mean, if they don't have an OMVS segment already in a home directory, can you please give them one? It is, what year are we now? 2018? Okay. Okay, that's enough sarcasm for that one. So that's Please do that. That is an important one in this environment. There's one other thing I want to say. I show everything via IDZ for a reason, because I really think you should be using a modern IDE. There are a few people in your company that might not want to use a modern IDE. The Git client is fully running on Z, so they can go to the command line in ZOS, and they can do a Git clone into their own private directories. They can use ISPF to edit those files, and they can issue the DBB scripts from the command line to run. So you're actually not stopping an ISPF user from doing their job. They can still do their job in ISPF. We're just not highly recommending it, and I'm not showing it. So this isn't making it impossible for somebody who really loves ISPF to keep using ISPF. For everyone else in the world, they get their modern development environment, and we move on. Okay. Other questions? And I just run out of time anyway, but any last questions? If not, I'm here all week. I'm happy to answer questions. There'll be people around the trade show possibly who might answer questions about this, but they'll also answer all the questions about IDZ or RTC or other things. And if you want to know a lot about IDZ and or all of the modern IDEs, there is the IDE shootout that will be held later in the week, and you can go see all the IDEs side by side to demonstrate why you never want to use ISPF again. Thank you. And don't forget session evaluations. We care.